Welcome to lesson 7126, trigonometric functions of any angle. Okay, let's look at our vocabulary, initial side, terminal side, vertex. We had this in geometry. So let's refresh our memory. All right, here's some more. Measure of an angle, positive angles. Negative angle, coterminal angles. We're going to use that. So take time, pause, and read the definition. A reference angle. This is an important concept. Okay, now let's look at this. Quadrant 1, theta is acute. Acute means less than 90 degrees. In quadrant 2, so what are quadrants? If we were to draw, I always forget to turn on the pen. I'm sorry about that, everybody. If we were to draw an XY axis where positive X, positive Y, negative X, negative Y. This is quadrant 1 going counterclockwise, quadrant 2, quadrant 3, and quadrant 4. Now, in quadrants 1 and 2, the Y is positive, so let's do this, and we had to remember this. I think I did this before. Not X. Remember, in a point, the X is always first, and the Y is always second. So, not to muddy this up. We got positive, positive. We get negative, positive. So in quadrants 1 and 2, our Y values are both positive. Our X changes. In quadrants 3 and 4, our Y values are both negative. So right of the Y-axis, the X values are positive. Left of the Y-axis, the X values are negative. Above the X-axis, the Y values are positive, and below the X-axis, the Y values are negative. So put that in our mind, and these are equations we're going to have to use to find angles. Then you got to know which quadrant our angles are in, so we have to know these in degrees and in radians. So if you don't remember, 0 to 90 or 0 to 89 or whatever, theta prime equals theta. So theta prime is just the adjusted angle. Or they give us 2 pi minus theta. Theta minus pi, 2 pi minus theta in quadrant 4. Okay, here is one more. Quadrantal angles. You may never see this, but I'm just putting this out for you. Okay, now coterminal angles. First, find and draw a positive angle and a negative angle that are coterminal with the given angle. Okay, so let's give you the angle first. Okay, so for A, 30 degrees. What is coterminal? So I'm going to add 360 degrees to it, and that gives me 390, which is bigger than 360. Or I could subtract 360 from it, so negative 360 plus 30. And a little bit of algebra. Larger number always goes on top. Same signs add, different signs subtract. Any number without a sign in front of it is positive. That gives us negative 330. So if I went around the circle in a positive direction, this will give me 390. If I went around the circle in the negative direction, not from here, I'm sorry, not from the angle. From the initial side. From the x-axis, not from where the angle is. If I went around, this would be negative 330 degrees. And that's all you have to do. Okay, let's find a coterminal angle for this angle. So what we're going to do is draw negative 150. So it always helps us to draw the angle first. So negative 90, and then go on another 60 degrees from there, puts us out here somewhere. So this is our angle, negative 150. Okay, so now First thing I'm going to do is find the positive angle. What is the positive angle that gets me to here? So I'm going to do 360. Same signs add, different signs subtract is 6 minus 5 is 1. 3 minus 1 is 2. That gives me 210 degrees. That's my positive angle, 210 degrees. And then if I draw another angle and I go from here and I go around again, I subtracted another 360. So if I do negative 360 minus 150, same signs add. That gives me 510 degrees. No, yeah, 11, 510, negative 510 degrees. Okay, so now let's look at our third angle, 2 pi over 3. All right, so what we're going to do here is this is a radian measure. So we're going to add 360 degrees, which is 2 pi radians, but we need to do some fraction magic. So 2 over 1, but we need the bottom to be 3. So if we multiply by 3 over 3, we get 6 over 3. So we're going to add 6 over 3 to pi, 6 pi over 3, and then 2 pi plus 6 pi is 8 pi over 3 radians. So 2 pi over 3. This is pi over 2. This is pi. 2 pi over 3. All right, let's see. Pi over 3 is 60 degrees. 2 pi over 3 puts us up here because it's bigger than 50. 2 divided by 3 is 0.6 repeating. 1/2 is 0.5. So that puts us right there. So if I go around from here another 360 degrees, I get to here. And then what I'm going to do is subtract 2 pi. So I'm going to take 2 pi and subtract 6 pi over 3. I could have just kept adding another 360, but we got negative 4 pi over 3 radians. So what that does is go from the x-axis out to here. And this is negative 4 pi over 3. And the red one is 8 pi over 3 because we went past the 0 or 360, the x-axis, and we kept going. So coterminal angles, they have the same terminal point. Okay, now let's start using our vocabulary words. Let theta be the acute angle in standard position whose terminal side contains the point 5, 3. Okay, so what do we mean? Your initial side is always going to be the x-axis, unless otherwise stated. Your terminal point, the x is 5, the y is 3. All points in the Cartesian coordinate system, x goes first, y goes second. Find the 6 trig functions. So we have, if I make this a right triangle, the y is 3 and the x is 5. So now let's do 5 squared, x squared plus y squared equals r squared, which is the hypotenuse or the other leg. So 25 plus 9 equals r squared. Oh, that should be green. R squared. And then this r is equal to the square root of 25 plus 9, which is 34. So r equals root 34. So now we know the sine is 5 over root 30, no, 3 over root 34. The cosine is 5 over root 34. We're going to fix the things in a second, but let's just get the basics. So the tangent is 3 over 5. Now, what's opposite the sine? is the cosecant. The CSC is equal to root 34 over 3. The secant is the opposite of the cosine, which is root 34 over 5. And then the cotangent is equal to 5 over 3 because we just flipped the values upside down. So 3 root 34 and 5 root 34 is equivalent to 3 root 34 over 3. So the sine is really 3 root 34 over 34. And then the cosine should actually be, if I was fixing these, because we can't leave a radical in the denominator, is 5 root 34 over 34. And that's what they should be. Okay. Now, let's look at a trig function by point not in quadrant 1. So, now we got the same thing, so I'm glad they did this for us. We got the same thing, but instead of positive 5, 3, we got negative 5, positive 3. So negative 5, positive 3. Our hypotenuse is still root 34 because that's left over from the last problem. And now let's do the sine, cosine, and tangent. The sine of theta, the ratio. And remember, these are ratios. These are measures of side lengths. Is 3 over root 34 because the sine is positive above the x-axis. The cosine is negative 5 over root 34. And in a fraction, it doesn't matter where your negative goes. It goes out front, go with the numerator, go with the denominator. It does not matter. The tangent of theta is 3 over negative 5. The cosecant is root 34 over 3. The secant is negative root 34 over 3. And then the cotangent is negative 5 over 3. And you saw me fix those on the previous page. So the sine is actually 3 root 34 over 34. And then the cosine of theta, I should write theta in there. I forgot to write the theta. I'm sorry about that. Is negative 5 root 34 over 34. All right, so now evaluate the trig functions of 315 degrees. So let's draw 315 degrees. It's bigger than 270, so 90, 180, 270. So this is one of our special angles. It's in quadrant 4, 314. Why not write 314, 315? So this tells us that the x is positive and the y is negative. We got a plus minus situation going on here. So the sine is going to be negative, but first thing I want to do is find a reference angle. And we saw on the page above, so go back, scroll back to that page where you saw where we had to find reference angles. So if in quadrant 4, we take 360 and we minus our angle, and we get 45 degrees. And so 45 degrees is one of the special angles we talked about in a previous lesson. And so now this becomes easy. The sine is root 2 over 2, but negative, because this side is root, I forgot to write that in right. So the hypotenuse, well, let's do it. A 45-degree angle has the same measure. So if this is 1, this is 1, this is root 2. The reason why I wrote root 2 over 2 is we can't leave radicals in the denominator. So let me erase this and start from the beginning. So this is actually -1 is the y value over root 2, but to multiply by root 2 over 2, top and bottom, gives us negative root 2 over 2. The cosine is positive 1 over root 2, because the x is positive, which gives us root 2 over 2. The tangent of theta, I keep forgetting to write theta in here, is -1 over 1, which is -1. Now let's go through the rest of them. The cosecant is opposite the sine, which is negative root 2 over 1. The secant, which is opposite the cosine, is root 2 over 1, which is just root 2. And finally, the cotangent is just -1, because -1 flipped upside down becomes -1. And that's how we find the all 6 trig functions of another angle. All right, so it says find the sine without a calculator. Hey, we got a calculator. Let's just plug it into the calculator and see. All right, so what you're going to do is look at your calculator, turn it on. Make sure at the very top it says normal, float, auto, real, degree, and MP. If that's in degrees, all you got to do is hit sine. Negative is down at the bottom near the decimal, so do not hit subtract, because that's going to give you an error. Close your parenthesis, and you will get 0.5, which is 1/2. Use a calculator if you got it. Now, sometimes you won't have a calculator, but we'll be able to figure these things out. What they wanted us to do was see that 210 is bigger than 180, so it's here in quadrant 3. So we take our angle, we add 180 to it, and we get -30, and then they want you to memorize the angles for 30 degrees. But we don't need to do all that. Or you take positive 210 and -80, and you get a positive 30. We don't need to do all that. Just use the calculator if you got it. So the tangent of 5 pi over 3. So now what you got to do is you got to hit the mode button, come down to radian, go over, hit enter, make sure radian is now dark. It has the highlight around it. Hit second mode to get out of there. Hit tangent. Hit alpha x to make a fraction. Do 5. Second caret. The caret is the key over the division symbol. And pi will pop up. Go down. Hit 3. Right arrow. Close your parentheses. Hit enter. And you'll get a fraction. -1.73 and a bunch of numbers. We don't care. That's good enough. But let's find the reference angle for 5 pi over 3. So pi over 3 is about 60 degrees. 2 pi over 3 is right there. 3 pi over 3 is right there. 3 pi over 3 is pi. 4 pi over 3. And then 5 pi over 3 is in quadrant 4, which means the x is positive, the y is negative, but we don't need to worry about that. The tangent. What is the tangent? The tangent is the y divided by the x. So that's 1, that's root 3. So actually, without finally using the calculator, so y divided by the x. So it's -√3 divided by 1. So let's see. So we, on our calculators, if we hit second x squared, put 3 in there, hit enter, we get the same number. So that's actually -√3 over 1. The secant is the opposite of the inverse, not the opposite, but the inverse of the cosine. not the cosine inverse, but the cosine x to the minus 1, which gives us 4 over thirds pi. And we saw that was in quadrant 3 from the last one. And so it's the same thing, but now it's the x value. Oh, no, it's not. That was the tangent. Oh, over the 60-degree angle. Here's our triangle, but this is 60, 2, 1, root 3. Oh, you don't flip the angle upside down. You only flip the ratio upside down. I don't mean to write that down. Sorry. I'm looking at that. All right. So the secant is equal to the cosine. So what you're going to do is you're going to do parenthesis, cosine. X is next to the green button. Close it again. The x to the minus 1 key is right above x squared. It's left of the 7. So go to the 7, go to the left, go up 2. And that's how you punch this in. Oh, we don't want x. I'm sorry, we want an actual angle. We want alpha x. We got -3, second caret, down arrow 4, delete the x out. So you got cosine of -3 pi over 4, 2 right arrows, and then the -1. Hit enter. And -1.414, which means this is -1.4. This is negative. So this is a 45-degree angle. So this is the square root of the negative square root of 2. If I hit second, x squared 2. Yeah, I get 1. Yeah, that's a 45-degree angle because it's divided by 4. Okay, so those things. Use the calculator. Get the ratios. These are the ratios as real numbers. Okay, again, using our calculator. Hit sign negative. Negative is down by the decimal of 270, which is the same as the sign of 90, which equals 1. The y value is 1, the cosine value is 0. The tangent of 3 pi, if you just push that in, tangent 3 pi is equal to 0. And then the secant of 11 pi over 2. The TI-84 does not have a secant button, so what you're going to do is the secant goes with the cosine. You're going to hit parenthesis, cosine, x, close the parenthesis. I'm not x. I'm sorry. I keep saying x. 11. No. Delete that out. Second. Not second. Alpha x. Then second. Caret. 11. Down arrow 2. The 11 pi should be first, but I wrote pi 11. Right arrow. Close the parenthesis. Close the parenthesis. Hit the x to the -1 key again, and we get a very, very small number, which means it's undefined. That must be at 90 or -270. So this is undefined. What you see on your calculator is 1E13. That means it's got decimal point, 12 zeros, and a 1. So we don't worry about a number that small. That's undefined. We could use one trig ratio to find the others. So we know the sine of 3 over 7. Find the tangent. And tangent theta is less than 0. All right, so the sine is 3 over 7. That means both ones are positive. So we got a triangle. Let's just draw a triangle first. So the hypotenuse is 7, the opposite side is 3. So if we take 7 squared minus 3 squared, the square root of that will give us the x value. All right, so 7x squared minus 3x squared equals square root of 40. All right, I'm not even going to simplify the radical. I'm going to just leave it like this because we want to find the other trig functions. Okay, so the tangent theta is less than 0. The tangent of this angle is less than 0. So that's what's throwing me off, people. All right, we know that they want the tangent to be negative. Where's the tangent negative? The tangent is negative in quadrants 2 and quadrants 4. Quadrants 4. I should have just wrote a 2 here. All right, the tangent is negative in quadrant 2 and 4. So that means that if we just put a negative in front of the x, so the sine is 3/7. The cosine is negative root 40/7. And then the tangent is 3 over negative root 40. So did they want, use the definitions to get the tangent theta. The tangent theta is 3 over negative root 40. I'm not even going to simplify this. We could simplify this. We could rationalize it. I'm going to stop right here. So I think they want us to find a tangent. I don't think they want us to find all 6 ratios. Okay, let's look at B. The secant is 3 and the sine is greater than 0. So where is the sine positive? In quadrants 1 and quadrants 2. So it could be in any one of these quadrants. So the secant goes with the cosine. So we're talking y over x. So the secant has a value of 3. So the secant is 3/1 because any whole number could be divided by 1. So the secant goes with the cosine. That means it's 1/3. The x value is 1. The hypotenuse is 3. 3 squared minus 1 squared is root 2. No, it's root 8. Sorry, root 8. 3 squared minus 1 squared is equal to y squared. 9 minus 1 is 8, so that's root 8. All right, so, okay, boom. Okay, so that's root 8, and the sine is bigger than 0. So the sine is just root 8/3. And that would make the tangent equal to root 8/1. Okay, for C. Doing C. The cotangent is undefined. So that means you're dividing by 0. So we have to figure out where the tangent is 0. So the tangent is 0 at 0 and 360 degrees. which is 0 and 2 pi radians. The cotangent is also undefined at pi radians, or 180 degrees. So that's where the x value is 0. The tangent is y divided by the x. The x is 0. If the y value is 0, then the tangent is 0. When you flip it upside down, you get the cotangent. You can't divide by 0. So we know that the tangent equals 0 in y, 1 in x. Okay, boom. We got that down. Our unit triangle. The secant is negative. That means the cosine is negative, so the x value is negative. Okay, so that puts us at 180 degrees, or pi radians. That's our reference angle. We don't have a triangle. We just have a straight line. Now, go do some practice problems.